The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a mathematical tool. Title of the video, Using a Single Abacus for Decimal Addition. Let us take the example 34.12 and 83.46 and see how this can be solved using a single abacus. As all digits of both decimal numbers are same, we can simply set this as 3412 and 8346 and adapt a normal procedure in addition. With the conversion into whole numbers, this is nothing but a 4-digit addition that we already know. The setting of the number 8346 and 3412 in the abacus will occupy 8 of the 15 columns, which is usual. The problem comes when the total number of digits of both the numbers go beyond 10 or 12 as setting numbers, as well as identification of the right place value might be confusing. In the current problem, let us set 8346 in the extreme right of the abacus. That is 8 in the thousands column, 3 in the hundreds column, 4 in the tens column, and 6 in the units column. Let us set the number 3412 in the left extreme of the abacus. For reference, let us start adding the numbers. 3 should be added with 8, which is not possible, and therefore add 1 in the 10,000s column and subtract 7 in the thousands column. Now 4 should be added with 3 in the hundreds column. That is, add 5 in the upper abacus and clear 1 in the lower abacus. Now 1 should be added with 4 in the tens column. That is, add 5 in the upper abacus and clear 4 in the lower abacus. Finally, 2 should be added to the units column. Now the total number we get is 11758. Now we have to reconvert the whole number into decimal number. As there are 2 decimal points, we can write down the result as 117.58 as the last 2 digits on the right should be earmarked for the decimal portion. Please note that we have treated the numbers as whole numbers and kept the decimal portion in memory, implying that 2 digits on the right should be meant for the decimal portion. If the child is comfortable using memory in the final writing of the results, the dot in the separating bar does not matter. In case the child wants to do the operation using the dots from the beginning, it can be very well done too, and let us see how it happens. Take the 83.46 and set the decimal part 46 to the right of the first dot on the separating bar and mark the number 83 on the left side of the dot. You can set the number 3412 on the left side of the abacus for reference. Now let us do the addition. 3 should be added with 8, which is not possible, and therefore add 1 in the 10,000s column and subtract 7 in the thousands column. Now 4 should be added with 3 in the hundreds column. That is, add 5 in the upper abacus and clear 1 in the lower abacus. Now 1 should be added with 4 in the hundreds column, that is add 5 in the upper abacus and clear 4 in the lower abacus. Finally, 2 should be added with 6, that is making it as 8. Now the total number is 117 followed by a dot and 58. In the result, we get 3 numbers to the left of the dot on the separating bar, that is indicating the whole number as 117. On the right of the separating dot, we have 2 numbers 5, 8, that is indicating the decimal part. This way, the result is shown exactly in the respective places where the decimal part is distinguished from the whole number part. This exercise demonstrated how the decimal addition can be done using a single abacus and also treating the 2 numbers to be added as whole numbers. In the next exercise, let us see how a single abacus can be used for doing the same problem but treating the whole number and the decimal part separately for addition.